Some videos ago, we modeled trends, right? And we saw that this random walk model with drift, so this is the stochastic drift term, this beta note, and this is yt equals the drift plus the value of the y process in the previous time period plus this error term. And what you can say about this model is that, or this process of yt, is that if you start at one point here, and this is time 0, and if you would like to know the process, the value of the process at time 1, it would be the sum of the value from the previous time period. This would be that number, and you would add the drift term. So probably the drift term would be a positive number, and you would add the random error term, for example, even higher here. So this would be the new or the value of yt at time equal to 1. And you would continue this and make the value or get the value of this process for the next time period. You just have the value of y at time 1, and you add the drift. The drift is constant, so in this framework, and then you add the random error term. Maybe this time it was negative, so by quite a bit, so the new value is here. So this random walk actually kind of evolves according to this equation. But we saw that if you have a starting point here, and you just make a lot of simulations of this process, then you would get a process which kind of fans out like this. So the variance of the process is increasing, and this makes this random walk model non-stationary. What we also learned was that if you have a non-stationary process like the random walk, then hypothesis tests are quite unreliable. So we need to have a stationary process if we are to use the ordinary tools, the statistical tools that we learn in this course. So if yt follows a random walk, then delta yt is stationary, because what we saw was that if you have this random walk, then beta naught plus beta 1, or beta 1 equals 1 in a random walk, plus the yt minus 1 plus u. So if you subtract yt minus 1 from both sides, t minus 1, then these are negated, so you are left with the difference in yt equals beta naught plus u. So this process, this difference, is just randomly, let's see, I have to remember the subscript here, is randomly evolving around the beta naught, which is a constant. So this is this process, this difference in yt is stationary. If we were to draw this this process, then we would have delta yt here and t here. Then we would have beta naught here, and we would kind of have this process which is which has the same mean and the same variance no matter which time period you are looking at. So this is stationarity. But the random walk is quite useful for many time series in economics and finance, but some time series have really smooth trends, and if we were to describe them, we need a different model than the random walk. One model of such a smooth trend is a model where the difference in y is following a random walk. And in this case, the first difference is non-stationary, so we need to difference the difference. So then we get the second differences of yt. To see which process generates this non-stationary first difference process, then we can just take this difference, and we have the difference of yt equal to beta naught, the constant, plus delta yt minus 1, which is the lagged difference, plus ut. And this difference is just yt minus yt minus 1, and the constant remains, and this lag difference is just yt minus 1 minus yt minus 2. And we have to add the error term. So here we can just add yt minus 1 to each side, and we are left with yt on one side and the intercept plus 2yt minus 1 minus yt minus 2 plus the error term. So this process here, yt equals to a constant plus 2 times the first lag minus 1 times the second lag, actually creates a process in which the differences is non-stationary. And if you have this this problem, you have to difference yet again, so you get the second differences of y. So to sum up the idea of a trend or non-stationarity, then we can look at equation 3, which is yt equals beta naught plus yt minus 1, or beta yt minus 1 plus the error term. So this is the random walk model if beta 1 here is equal to 1. And the fourth equation here is that the delta, the change in yt, or the difference in yt, is a random walk itself. So this is the lag difference and ut. Okay, so if our time series does not have a stochastic trend, you can test whether or not it has a stochastic trend by using the augmented Dickey-Fuller test. And if the null hypothesis in that ADF test is rejected, then you say that this is a stationary series. So it's already stationary. It does not need to be differenced. So it's integrated of order 0, or I0. So if the original time series is stationary, then then you do not have to do anything with it. You can just use it as is in your analysis. But if the series has a random walk trend, then you have to difference this time series, which is like this in equation 3. Then you have to difference it once to make it stationary. And then you say that it's integrated of order 1, or I1. So now you can just difference the series once, and you can use it in your statistical analysis. Just work with a time series of differences. But if the difference of the series is a random walk itself, like this, then you have to difference the time series twice. And then you say that the time series is integrated of order 2, because you have to difference it twice in order for this to be a stationary series, or you say that it's I2. So the second difference is stationary. So this is now your time series which you want to work with. So the order of integration is just the number of times you have to difference a time series for it to be stationary. But it's really important to know that you should not difference a stationary series, because then you can induce a so-called moving average process into your different time series. So you have to be very particular on which order of integration your time series really is. So start off with the original series and use the augmented Dickey-Fuller test, and if your test returns that it's non-stationary, then you difference once and check again. And if it's still non-stationary, then you difference again and you just check. So you just continue like this until you have a stationary series. But a series of integration of order 3 is extremely uncommon.